Our next lesson in geometry is called Meaning of Similarity Theorems. So let's go ahead and take out our notes. Let's write today's date. Meaning of similarity theorems. Alright. Our goals today are to prove when triangles are similar and to know important facts about similar triangles. Alright, I don't see any vocabulary words. Okay. So, meaning of similarity using theorems. Okay, in the last lesson, you were introduced to the concept of similarity. So we're going to expand on what you learned. And we're going to show how you can prove that some triangles are similar. If you get your theorem sheet and you write these theorems on your theorem sheet, you may use that on your quizzes and your tests. Okay? You don't have to memorize the names of the theorems, but it's important that you understand how to use them. In the last lesson, we used Theorem 5.1, and we showed how to prove that two triangles are similar. So the next two theorems are ways to prove triangles are similar. Okay. Make sure that these are on your theorem sheet. Okay. Theorem 5.2 is known as the side angle side theorem. It states that if you can prove that two sides and the angle between them are similar on two triangles, then you can prove that the two triangles are similar. Okay? That means that the angle between the two sides, like if we're proving that this side is equal to this side, and this side is equal to this side, and this angle, well, I shouldn't say equal, but similar. The angles are equal. Then you can prove that they're similar. You can prove that the sides are similar and the angles are equal. Then the triangles are similar. Remember, similar does not mean the same size. It means it's proportioned. Okay? Okay. Make sure you write this theorem out on your theorem sheet. And then there's Theorem 5.3. Okay. This is what I want in your notes. On your theorem sheet, I want you to write this and I want you to write it out. Okay? Are you understanding that? Whatever I write here, I want in your notes. Okay? Theorem 5.3 is called the side-side-side theorem. And that states that if you can show that these three sides of one triangle are similar to these three sides of another triangle, that means that both of the triangles are similar. Okay? We do not need the ASA, remember angle, side, angle, or the AAS, angle, angle, side theorems to prove similar triangles now, because we would already have two angles equal, enough to prove the triangle similar by the AA theorem. In the SS an SSA theorem is not true. So there's no such thing as a side-side angle theorem. There is no side-side angle theorem. Because just because they're similar doesn't mean the triangles are similar. Okay? A summary of the ways to prove that triangles are similar is given. The theorems and postulates used to prove similar triangles are much the same as those used to prove congruency. The difference is found in the definition of similarity. Remember, for a polygon to be similar, the angles must be the same, the angles must be the same, and the sides must be in proportion. Okay? We have a side angle theorem, but that angle has to be the angle that these two sides are connected with. Okay? Because the side-side angle theorem is not true. Just because you have two triangles that the sides are similar and this angle is equal, if the angle is not between the two sides, then it doesn't prove that they're similar. Okay? Okay, let's do one of these together. Okay, let's say I have two triangles. Here's my first triangle. I have A, B, C. And over here I have R, S, T. Okay. I'm going to make my own proof chart. I know that my chart has to say statement over here, and on this side has to be the reason. Okay, let's say that it's given that AB over RT equals BC over ST equals CA over RF. Okay, so AB over RT equals BC over ST equals CA over RS. We know the first reason is always given. Okay, we're trying to prove that triangle ABC is similar to triangle RTS. Okay? Number 2, I'm going to draw okay. I've just never seen them do it this way before, so that kind of threw me, but it's okay. It says draw XY parallel to TS so that CA equals XR. Okay, so I'm going to draw a line parallel to TS so that it equals this. Okay. Okay, so this is going to be X, Y. And this is definition of an auxiliary line. So I'm just going to put AUX line. I drew a line so this smaller triangle is equal to that triangle. is what it did. Okay? Okay, so now I can say number 3. I can say that triangle RYX, is similar to triangle RTS. Okay? This is the AA theorem, angle theorem. Okay? Okay, now I'm going to have to erase part of this because I'm out of room. So now we know that triangle RYX is similar to triangle RTS. Alright? Let's go to number 4. Don't erase yours. Just keep going. I just ran out of room. Okay, so number 4 says RY over RT. RY is to RT as YX is to ST as XR is to RS. Okay, so RY is to RT as YX is to ST as XR is to RS. And this is the definition of similar polygons. Definition of similar polygons. Okay. Now that we got that, now all we have to do is substitute. Okay? So let's do some substituting. Number 5. Okay, RY is to RT. Let's keep that part. RY is to RT as YX is to ST. We're going to keep that part as, instead of XR, we're going to substitute CA because we said these two sides are equal, right? So instead of XR, we're going to put the CA there instead, as CA is to RS. And all we did was substitute. Substitution. Okay? Now number 6. Okay. Instead of RY, we're going to substitute with AB. Okay, so AB is to RT as, this is a 6, by the way, this isn't writing real well, is it? As I'm just trying to figure out where we got this. Okay, AB over RT equals, okay, AB equals RT, okay, as RY, okay. So instead of AB, we're substituting RY. That's what they did. Okay. RY is to RT. And still on number 6. Still on number 6. I just ran out of room. And it says BC is to ST as okay. BC is to ST. Instead of BC, we're going to put the XY in there because remember we said that those were equal. As XY is to ST. And again, this was substitution. Okay. So the next step would be, well, I didn't put on here what you were supposed to prove, so maybe, I guess I forgot to write it. We're supposed to prove that triangle ABC is similar to triangle RTS. Okay? That's what we're trying to prove. So let's look at number 7. Okay, number 7 says, well, let's look. If these are similar, that means look at the top one. That means that AB equals RY, and it means that BC equals XY, right? We proved that in the last step. We're just going to rewrite it. AB equals RY, and BC equals XY. Okay? Now I'm going to have to get me a different marker. Okay, so number 7, this is the multiplication property of equality. And what that means is AB equals XY because we divided them both by the same thing. Okay? Here, BC equals XY because if you can divide them both by the same thing and they're still equal, that means that they're equal. So this is the multiplication property. Multiplication property. So look what we have. I guess I should have said it before I erased it. But we said that okay, we have these two sides are equal. We have that BC and XY are equal. Let's see. And it was given that we'll have to figure out. On step number 2, when we drew this line, we said CA equals XR. So we have all three sides. Okay? So we have all three sides. So we know that triangle RXY, or RYX, equals triangle ABC. And we know that because it's the side, side, side theorem. If you can prove that all the sides are equal to each other, then you can use the side, side, side theorem and prove that the triangles are equal. But remember, I'm trying to prove that this triangle is similar to this large triangle. Okay, so I'm almost done, but I'm not quite there yet. Okay, number 9 says, okay, now remember, these angles in order are equal. Look, angle R equals angle A, angle Y equals angle B, and angle X equals angle C. Alright, so angle A equals angle R and angle B, angle Y equals angle B, right? Angle Y, the second one equals angle B. Okay, and that's the CPCTE. CPCTE. Corresponding parts of current coordinating triangles are equal. Okay. Alright. Okay, so let's look at number 10. Number 10 says, triangle RYX is similar to triangle ABC. I think they did this the long way, but if they're similar, if they're equal, they're also similar. Okay, we proved that they're equal, so we could have went straight from 8 to 10. We wouldn't have had to have number 9 there, but triangle RYX is similar to triangle. It's supposed to be a triangle, by the way. ABC. This is the AA theorem. Okay, let's look at number 11. Number 11 says triangle. Okay, if triangle RYX is similar to triangle ABC, okay, we can switch them, right? So I can put the ABC first. So instead of, I'm going to say triangle ABC, I'm going to put it first. It's similar to triangle RTS. And this is the AA theorem. Okay. And we probably could have done it in less steps than they did. Just take your time. Alright. Make sure you have those theorems and postulates on your theorems and postulates sheet. I want you to, well, here we'll do some together. Let's look at number 1. This is number 1. Number 1 has a picture. It looks like this. This is A, B, C, D, E. Okay, if these two lines are parallel, then triangle, okay, if, I'm not going to write that. If those two lines are, assuming that these two lines are parallel, triangle DAE is similar to what triangle? Well, it's obvious since there's only one other triangle there. But you have to put these in order, okay? Which point is similar to B? D. It would be B, right? So the B has to go first, and then the angle, and then C. Okay? Guess I should have given you a chance to answer that first. Okay. Number 3. Using the same triangle, using the same diagram, this diagram, if angle BAC is equal to angle E, okay, where am I at? Okay, BCA. So if angle C is equal to angle E, we're going to say that these two angles are equal. If they're equal, well, I just gave you the answer. That was my fault. I read it wrong. If angle C equals what angle, then triangle ABC is similar to triangle ADE. For that to be true, angle C has to equal what angle? Well, it has to equal angle E. I read that problem wrong. You lucked out on that one. Let's look at number 5. Okay, I'm not drawing this, so here you go. Here's your triangles. Which of the triangles shown is similar to triangle C? Okay, well here's triangle C, right here. Which one of the triangles are similar to triangle C? Well, I don't know if you can see that or not. It says that this is that picture. That means that's a right angle, means it's 90 degrees. And this is 30 degrees. Okay, let's do it this way. I didn't want to draw them, but you're not going to understand it if I don't. Remember, triangles have to equal, the angles of a triangle have to equal 180 degrees, right? So if I have a triangle, this is triangle C, and triangle C looks like this. Whenever you have a square, that means 90, right? And this right here is 30. What does this other angle have to equal? We'll have 90 plus 30 plus, I'm going to say x, equals 180, because every triangle has to be 180 degrees. Just a second. My marker officially died. Let's use a different marker. Well, 90 plus 30 are 120 plus x equals 180. Okay, which one's like 180? Well, the 120, so I have to subtract 120 from both sides. These cancel out. I get x equals 60. Right? So this has to be 60. So I just look at the choices until I see which triangle has a right angle and a 60. And I know you can't see the choices. But if you look at the choices, your answer is going to be H. Okay? Okay, that was number 5, by the way. Okay, number 7, true or false? All isosceles triangles are similar. True or false? Well, an isosceles triangle means that two sides are the same length, right? So if I have an isosceles triangle, those two are the same. Okay, if I have an isosceles triangle here, okay, let's look. Well, my answer is going to be false. Okay. Okay. All isosceles right triangles are similar. True or false? Remember, number 7, there's no side-side angle theorem. Just because the sides are the same doesn't mean the angles. Just because the sides are congruent doesn't mean the angles are going to be. Okay? But number 9 changed the rules. Number 9 said all right triangles that are isosceles triangles are similar. Well, if we draw this, we know this is 90 degrees. Okay? And if this is an isosceles triangle, if both of these are equal, then I have what you call a side angle side. Remember our side angle side theorem? So this is going to be true. Okay? Let's look at number 11. Alright. Okay, number 11 and number 13, you have some proofs to do. Okay? Go ahead and show me your notes, study this lesson, and go ahead and answer the questions.